Okay, now we're going to start chapter 4. And so we're going to start out talking about exponents and our rule for exponents. So recall that in the expression 5 squared, the number 5 is called the base and 2 is the exponent or power, right? The expression 5 squared is an exponential expression. So if you don't see an exponent written, it's understood to be a 1, right? Okay, so what this means is 3 factors of 2, the 3, how many of your bases you have, that's the exponent. And we can see from here that that's 8 because 2 times 2 times 2 is 8, not 6. Don't multiply the exponent times the base, right? This means you're going to multiply 3 2's times themselves. Okay, so identify the base and the exponent of each expression, then evaluate. So the main thing we have to be careful about, one of the main things we have to be careful about, is that the exponent only goes on the specific thing it is sitting on. Right here in this expression, that exponent has nothing to do with that negative, right? The exponent only goes on the one thing it is sitting on. So this is saying that's negative, nothing to do with the exponent, and then there's 6 2's multiplied together. 1, 2, 3, 4, 5, 6. So, well, we didn't really answer the question. Identify the base, okay? So the base is 2, okay? And of course the exponent is 6, okay? The base of the exponent is the one thing that the exponent is sitting on. Okay, so now I have one negative in a bunch of multiplication, so my final answer is going to be negative. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Now down here, the one thing that exponent is sitting on is a parenthesis. That means everything inside the parenthesis is the base. This is what the base looks like if you want the whole negative 2 raised to the 6th power. And of course the exponent is still 6. So this is 6 negative 2's being multiplied together. Whereas up here it's just 6 2's and 1 negative. So see the difference? 1, 2, 3, 4, 5, 6. And because it's all multiplication, an even number of negatives multiplied together is a positive. And then we already did what's 2 times 2 times 2 times 2 times 2 is positive 64 in this case. Okay, same thing if you have something like this, 3 times 2 squared versus 3 times 2 squared, right? Over here, this is 3 times 2 times 2. But this is actually 3 times 2 times 3 times 2. So pay attention. The exponent goes on the one thing it is sitting on. If it's sitting on parentheses, it goes to everything inside the parentheses. Careful about that. These negatives, this really gets people. So be very careful about that. Okay, here's the rules that we're going to talk about today, and then on the next video, then we'll get the rest of the rules. But right now we're just going to do the product rule and the power rules. So if you are multiplying 2 exponential numbers together that have the same base, they always have to have the same base or you can't combine them. So if you're multiplying them, all you got to do is add the exponents. Okay, so let's look at why that is. It's nice to see why. Let's say we had x squared times x cubed. Let's think about what that is. Oh, x squared means, hey, I'm going to multiply 2 x's together, right? Multiply 2 x's. And then I'm going to multiply it by 3 x's. Oh, look at what that is. Altogether, it's just 5 x's being multiplied. So 2x's times 3 more x's, 5x's altogether. Okay, and then we've got our power rules. Let's look at that. Let's say we've got x squared cubed. Well, what this says is, hey, this says multiply 3x squareds times itself. X squared, x squared, x squared. But each x squared I can write as x times x, right? X times x, x times x. How many do you have altogether? 6 x's. Oh, that's the same thing as just multiplying. So our power rule says if you have an exponent raised to an exponent, just multiply the exponents together. Okay. Now, if anything's being multiplied or divided, be very, very careful. These rules, there are no rules with a plus and a minus in there. Okay, we'll look at that in just a minute. So let's say you had xy squared. Oh, think about what that is. It's just xy times xy. But multiplication's commutative. We could rearrange that, right? And see that it's x squared y squared. Okay, same thing here. If you had an x over y squared, well, that's just x over y times x over y. And because the way fractions work, you multiply numerators together and denominators. Okay, so it's real easy to see why these rules are what they are, but there is no rule for this. This is not x squared plus y squared. Let's use a couple of numbers. 2 plus 3 squared. Is that 2 squared plus 3 squared? Okay, 2 plus 3 is 5 squared. Is that 4 plus 9? No. Very careful with plus and minuses, right? I tell all my students, think of that plus like a cross. Hold it up with your fingers. Ah! Anytime there's a plus or a minus, because all a minus is adding negatives, right? So it's really all plus. A plus or a minus, don't do it. There is no shortcut. None of our rules, none of our properties, anything with a plus and minus has a shortcut or a rule. Always only with multiply and divide, multiply and divide. So be careful if you have plus signs in there. All right, so let's see if we can apply these rules to some actual problems. Okay. So use the product rule for exponents to simplify each expression if possible. And I'm sure on these, it did not say, but on your homework, on these kind, it better. If it doesn't, send it to me in that Ask My Instructor button. But it should just want you to write it in its exponential form. Now, technically, you never leave a number with an exponent on it because that could be simplified. We could do the math. But if they're going to give you something like 7 to the 8th power, there's no need for you to have to, without a calculator, multiply 7 times 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 7, right? No need. So this is fine to just say, oh, now look, the bases have to be the same, and they are both -7. So this is -7, and I got to keep it in parentheses because that negative is being applied, the exponent is being applied to the negative because it's sitting on parentheses. And then 5 plus 3, here's 5 of them multiplied together. And then there's 3 more, so altogether there's 8. Okay, now I could simplify this a little bit more because I know I'm not going to figure out the actual numerical value, but I know that 8 negatives, the answer is going to be positive. So I could at least simplify it a little bit more. Okay. So down here, Okay, if I get rid of these parentheses, everything's just being multiplied together. I can multiply the -4 and the 3. And then because these bases are the same, I can combine those into one base. Since it's p to the 5th being multiplied by p to the 8th, my rule says, oh, I add exponents. 8 and 5 is 13. Notice this 5 had nothing to do with that negative or that 4. And this 8 had nothing to do with the 3. It's not on the parentheses like it was in the previous problem. So this exponent applies only to the p, and this one only to the p. Okay, remember if there's not an exponent written, it's understood to be a 1. So because the bases are the same, I can combine those as long as there's no plus or minus. I can combine those into the same base by adding the exponents. Same thing here, they're all z's. So, and it's all multiply. So here's 2 z's, 5 more z's, 6 more z's, all being multiplied together. So in reality, there's 13 z's all being multiplied together. Okay, here I have no rule for this, no property whatsoever, because the bases are not the same. The bases are not the same. So all I can do for this is say, well, 4 times 4 is 16, and then multiply it times 3 to the 5th. That's about the limit of what they should ask you, and I would hope they wouldn't even do that. But 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, and then figure out what that is. Okay? Hopefully, on your instructions on your homework, it will tell you if it's giving you ones like this or that -7 to the 8, and it will say leave your answer in exponential notation, and that's all you can do with that. You can't simplify it anymore unless you found the numerical value of each one. So this isn't the final answer. You need to go and do 243 times 16 and see what that is, right? And then plus 243. So for our final answer, what do we get? 38888. Okay. Okay. Up here, whoa, plus, plus, plus. No, you cannot combine those. There is no rule for that. It's just like this one down here. The bases are not the same. Plus sign, no. So all I can do is figure out what 6 to the 4th is, right? 6 times 6 times 6 times 6, and then plus 36, and add those two numbers together. So 36 times 30, once again, hopefully, if they give you one like this, I want you to recognize that's it. That's as simplified as it gets without going in and finding the numerals, but hopefully they'll give you something like this, x to the 6th plus y to the 4th. And then you can say, oh, I can't do anything further with that because it's a plus x to the 4th, because it's a plus, right? Because it's a plus. So if they wanted you to work this out, go over to the side and find out what 6 times 6 times 6 times 6 is, and then add 6 times 6 to it. I'm not going to take the time to do that right here. Okay, here's our idea that we want to know. If it's a plus, I don't care if the bases are the same or not. Right? I don't have a rule for adding. If it's multiply, the bases have to be the same before I can combine them. Okay, now power rule. So all I have to do is multiply the exponent. So this is 6 to the 10th. And again, it really annoys me that they give you numbers like this. I'm sure your homework is telling you leave it in exponential form, so you would leave like this. There's no way I want you to multiply 6 times 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 6, right? It's ridiculous that they give you these with numerals. This should be a problem like x squared raised to the 5th, and what's your rule? Multiply the exponents. Okay, like this one, 4 times 5 is 20, so that's z to the 20th. Okay, now I've got an exponent here on parentheses. It means it goes to everything inside the parentheses. This is another major problem people have is for some reason they forget to apply it to that number. So 3 to the 5th times a to the 2 times 5 is 10. And remember, that's because there's a 1 there. So 1 times 5 is 5. B to the 4 times 5 is 20. Now I can see them asking you to do, like I said a while ago, that's about the limit of the number that they should ask you to do. And we just did that. So remember it was 243. A to the 10th, B to the 20th. If you have a base of a 2 or 3, you can get your exponent, fairly large. But with bigger numbers and bigger exponents, there's no need to do that without a calculator. All right. Now, the negative also gets applied to that exponent, but 3 negatives means that's going to stay negative, right? 3 negatives multiplied together gives a negative. And then that would be 3 cubed, because that's a 1. And 2 times 3 is 6, so m to the 6th. So 3 times 3 is 9, times 3 is 27. Okay, some more. Everything inside the parentheses. So this is 3 cubed over x cubed. 3 times 3 is 9, times 3 is 27 over x cubed. That exponent goes on everything inside the parenthesis as long as the only things inside the parenthesis are being multiplied or divided. No plus or minus. So this is 1 to the 5th over 3 to the 5th. Well, 1 multiplied times itself 5 times is still 1. And we've done that 3 to the 5th already 2 or 3 times here. It's 243, right? All right. Okay, so on this one, I have 1 to the 4th, 5 to the 4th. Right? That's outside the bound, really. I'm sure they expect you to do that one, but that's a little ridiculous. Okay, so that takes care of this. But then it's times. Now, if any of them are fractions, I want them all to be fractions, so I'm just going to leave that like that. And then it's 2 squared times x squared. Getting rid of the parentheses because there's nothing inside the parentheses to do. So I can get rid of the parentheses this way. So then on top, 1 to the 4th, 1 times 1 times 1 times 1 is 1. 2 squared is 4. So I have a 4 x squared on the top. And then on the bottom, 5 to the 4th is 5 times 5 times 5 times 5. So 25 times 25. Okay. So we're going to think about, an easier way to do this. Think about this. So it's 25 times 5. What's 5 quarters? Oh, that's $1.25. Well, what's $1.25 times 5? All right. $6.25. Or however you want to do your multiplication there. But when it's 25s, if you think about quarters and then money, it makes it a lot easier. All right. So on this one, nothing to do inside the parentheses. If there was, I'd do that first and make my math easier. So I got a 5 squared, a k what? 3 times 2, right? And a 3 squared. So that's 25 k to the 6 over 9. And then finally, okay, so 3 negatives is a negative, so it's going to stay negative. 3 cubed, x cubed, y to the 2 times 3 is 6. And then again, it's times x to the 2 times 4 is 8, y to the 4th. But this time I'm not finished because I still have some bases that are the same. Okay, so I can now make this negative 3. Oh, let's get a number for that. 3 times 3 is 9. 9 times 3 is 27. So negative 27. Okay, done this part. Here's 3 x's and 8 more x's. So altogether, that's 11 x's being multiplied. 6 y's times 4 more y's. So 10 y's being multiplied. Now I have one number without an exponent on it. 1x, 1y. Okay, we'll talk about the rest of the exponent rules next time.